What is the acceleration of a unicycle that goes from 3 meters per second to 5 meters per second in 7 seconds? So if I'm drawing the diagram, here's my unicycle. Okay? It's going forward, and it's getting faster. So I would draw an acceleration in the direction it's going, and I just draw A underneath of it. That way it helps you figure out direction of which way it's going more. Okay, now I'm going to do the same thing I did on the other side. I'm going to write down what I know. I'm going to write down what I'm solving for. What is the acceleration? So A equals question mark. It goes from 3 meters per second to 5 meters per second. So we've got 3 meters per second for V and 5 meters per second for V. How can I have two velocities? Well, I can't. So I have to have different names for these. They can't both be V. So they're not. This is how fast I was at the beginning. We're going to call that VI. This is how fast I was at the end. We're going to call that VF. VI stands for initial velocity. And VF stands for final velocity. Okay, so VI is what you start at. VF is what you end at. And that goes in 7 seconds, so that would be my T. Okay? Here's my equation. A equals delta V over T. We're using that for acceleration. All right, first question you may have is, what in the blue blazes is this triangle business? There's a decent chance you've never seen that in a math equation before. So if you haven't, triangle is the Greek letter delta. Technically capital delta, but that's not that important. It means change in. So delta, the triangle, means change in, ... It means change in whatever comes next. You will never see delta by itself. You'll see delta V, delta X, delta T, delta Y, delta Q, delta F. You'll see delta whatever. But it's always the second thing of what it is you're changing. So, delta V then means change in velocity. And you may be saying to yourself, okay, great, Mr. B, I know what it is. I have no idea what to do with that. Here it is. Here's how you find delta V. You take the final minus the initial. So you take what you ended up with minus what you started off with, and that is your change. That's your delta V. And then you use that to solve the A equals delta V over T. So here's what it'll look like for me. Again, minimum setup. Here's my knowns and unknowns. Now I'm going to set up the equations. So I need to know what delta V is, right? So A equals delta V over T. T is 7 seconds. So I need to figure out what delta V is. I'm going to do that down here. Delta V equals final, which the final velocity is 5, minus the initial, which the initial is 3. So 5 minus 3 gives me 2. That's my value for delta V. That goes on top. 2 over 7 is 0.28. Okay. And that's your answer. Unit is meters per second squared. Again, if you don't have that memorized yet, it's meters per second, that's velocity, over seconds. So if you do meters per second, that would be meters per second squared. All right, I want you guys to try 4, 5, and 6. Now, if you're not done on the velocity side, go ahead and do 4, 5, and 6 here still. Okay, if you're not done on the front, do 4, 5, and 6 on the back anyway. You'll have time to go back to the front if you need to. But I want you to work on 4, 5, and 6 so I can answer any questions there and make sure you're on the in good shape. When you finish practice 1, let's be optimistic. When you finish practice 1, not if. So when you finish practice 1, go on to practice 2. You now have enough information to do practice 2, the front and the back. So go ahead and see what you can do on the back page. And we'll talk about it here in just a minute. We already have what is A, what is the acceleration. We've already got it goes from 13, that's VI, that's excellent. It does it in 6 seconds, that's excellent. But then the question I was given is, what's V final? Because I can't not know A and VF. I have to know one of them. I have to know A or I have to know VF. I can't not know both. So, what is the V final? So the question is, how fast is he going at the end? And it's in here, it's just not obvious. 0. How do you know it's 0? Yes! Okay, this is something to get used to. I'm going to do it to you all the time. Rest means 0. If you see it ends at rest, it means VF is 0. If it says it starts from rest, VI is 0. If it says it stops, VF would be 0. It started, stopped, or it wasn't moving, or anything like that means either VF or VI is 0. Okay? Just because it doesn't give you a number doesn't mean it doesn't give you a number, if that makes any sense. So just because you don't see a number doesn't mean you don't know what it is. And this is, again, the first time seeing it, so it's easy to miss that. So V final is 0. Now you've got enough to solve this. Now you've got enough to solve this. Okay? Perfect. Keep going with that. Keep at it. See what you guys can do. We got the setup here. Be really careful. I need to find delta V first. Okay? So I'm doing that. Remember, delta V is final minus initial. Here's what people think delta V is. People think delta V is big minus little. That is not what delta V is. Delta V is final minus initial. My final, it ended at rest. So it's 0 minus 13. It is not 13 minus 0. That means delta V is negative 13. That means A equals negative 13 over 6, which should be 2.16. Negative 2.16. So be careful there.
Can you round up?
Yes, you can. Like 2.17, you mean? That's fine. Okay, what is the final velocity for a roller coaster? It starts at rest, accelerates at a rate of 50 meters per second squared for 0.8 seconds. So what is the final velocity, VF, for one that starts at rest? So VI is 0. Accelerates at a rate of 50. And does it for 0.8 seconds. That's time. All right, had a great question asked. Do I need to square the 50? If it's 50 meters per second squared, do I need to square the 50? And the answer is no. And the reason is, the meters per second squared is a unit. It's not an equation. It's just a unit. It's not part of the equation. Now, if the equation was a squared equals delta V over t, then yes, you would square the acceleration. But the equation does not have a square, so just because the unit does, doesn't mean you do a square or a square root or anything like that. Okay, final velocity. In order to find final velocity, I got to do the delta V. So delta V equals VF minus VI. VI is 0. The problem is I don't know what delta V is. I can't solve VF unless I know what delta V is. So let's find delta V. How do I do that? The other equation, A equals delta V over T. So A equals delta V over T. And a lot of people told me correct on this. Opposite of dividing by 0.8 is to multiply by 0.8. That makes the 0.8 go away over here. Ends up over on this side. And 50 times 0.8 is delta V of 40. Now, put that 40 up here for delta V. So now I got 40 equals VF minus 0, and VF is 40. Now be careful, it's only the same as delta V because VI is 0. If VI was not 0, you wouldn't get delta V and VF to be the same number. So don't assume they're always the same. But frequently they are. Frequently they are, but not always. Okay. I'm going to make one more loop around.